This video will cover formulae and variations, including direct proportion, inverse proportion, and joint variation, as well as their graphical representations. We often want to see how changing one variable affects a subject. For a circle, the circumference c is equal to pi times diameter d. If we double the diameter, the circumference also doubles, as 2 times pi d equals 2 pi d. Our learning intention for direct proportion is to explain the term. Our success criteria are to understand the idea of direct proportion and solve simple proportional problems. Two quantities, like the number of cakes and the total cost, are in direct proportion if doubling one also doubles the other. For example, if 6 cakes cost £4.20, 5 cakes cost £3.50. This is found by calculating the unit cost of 70 pence per cake and multiplying by 5. Remember that the same ratio means the pairs are in proportion. Let's look at some examples to see which pairs are in proportion by checking their ratios. Which of these graphs represents a direct proportion? Direct proportion graphs show a linear relationship passing through the origin. Next, we will focus on inverse proportion. Our learning intention is to explain this term. The success criteria include understanding the idea of inverse proportion and solving simple inverse proportional problems. Inverse proportion is when one quantity increases as the other decreases. The quantities are inversely or indirectly proportional. For the table, notice that the product of x and y is always 80, confirming an inverse proportion. Here's an example. If 3 men take 8 hours to build a wall, how long will 4 men take? Since there are more workers, we expect less time. Using the easier method, the calculation shows it will take 6 hours. Another inverse proportion example. 10 men take 12 months to build a house. How long for 8 men? With fewer men, we expect more time. The calculation shows that 8 men will take 15 months to build the house. In this problem, a journey at 9 meters per second takes 32 minutes. How long at 12 meters per second? Higher speed means less time is expected. The calculation shows that at 12 meters per second, the journey will take 24 minutes. Now let's explore direct proportion graphs. Our learning intention is to explain why these graphs are always straight lines. Our success criteria are understanding that a direct proportion graph is a straight line and constructing these graphs. This table shows the cost of biscuits in pence per packet. Notice that cost divided by no of PKTs is always 20. This indicates a direct proportion, which means we expect a straight line graph. Plotting the data confirms a straight line passing through the origin. This represents direct proportion, with the cost C proportional to the number of packets P and the formula C equals 20p. A key point is that two quantities in direct proportion always lie on a straight line passing through the origin. Here's an example. We need to plot the points from the table, show they are in direct proportion, and find the formula connecting D and W. We plot the points 1, 3, 2, 6, 3, 9, and 4, 12. Plotting these points results in a straight line passing through the origin. Therefore, D and W are in direct proportion. To find the formula connecting D and W, we start with D proportional to W, which is D equals KW. Using the values D equals 6 and W equals 2, we find the constant K is 3. The formula is D equals 3W. Here's a summary of the steps for direct proportion graphs. 1. Fill in the table and construct the graph. 2. Find the constant of proportion, the K value. 3. Write down the formula. Question: does the braking distance D vary directly as speed S? The table shows braking distance for various speeds. We need to check if D over S is constant. Let's check if D varies directly as the square of the speed, S squared. The table shows S squared values. Fill in the missing S squared values, 100, 400, 900, and 1600. Now let's find the formula connecting D and S squared. D is proportional to S squared, so D equals KS squared. Using D equals 5 and S squared equals 100. K is 0.05. The formula is D equals 0.05 S squared. Now we transition to inverse proportion graphs. Our learning intention is to explain the shape and construction. Our success criteria are to understand the graph's shape and construct the graph to find its formula. This table shows how prize money is shared among winners, illustrating inverse proportion, since the product W multiplied by P is always 1800. We expect a decreasing curve. Plotting these points on a graph results in a decreasing curve, confirming the inverse proportion relationship. V is inversely proportional to n, which means V is proportional to 1 over n. A key point for inverse proportion is that two quantities always lie on a decreasing curve when graphed. Let's look at an example. Plot the points from the table, show they are in inverse proportion, and find the formula connecting V and n. We will plot the points 1, 1200, 2600, and so on. Plotting the points gives a decreasing curve, which confirms V and n are in inverse proportion. Note that V proportional to 1 over n yields a decreasing curve, while V proportional to 1 over n gives a straight line. To find the formula connecting V and n, we know V is proportional to 1 over n. The constant k is V multiplied by n, which is 1200 multiplied by 1, equaling 1200. The formula is V equals 1200 over n. In summary, the steps for inverse proportion graphs are: 1. Fill in the table and construct the graph. 2. Find the constant of proportion, k value. 3. Write down the formula. Now let's look at the learning intention and success criteria for formulae and variations. Our aim is to explain how to work out direct variation formulae. We want to understand the process and calculate the constant k to write the formula. Let's find the formula connecting y and x, given that y is directly proportional to x, and y equals 20 when x equals 4. Since y is directly proportional to x, the formula is y equals kx. Substituting the values gives 20 equals k times 4, so k equals 5. The formula is y equals 5x. The number of dollars D varies directly as the number of pounds P. You get $3 for 2 pounds. Find a formula connecting D and P. Since D is directly proportional to P, the formula is D equals KP. Substituting the values gives 3 equals k times 2, so k equals 1.5. The formula is D equals 1.5p. Now, a question related to the previous example. How much will I get for 20 pounds? We use the formula D equals 1.5p. Substituting P equals 20, we get D equals 1.5 times 20, which is $30. Let's consider a harder direct variation. Find a formula connecting y and x, given that y is directly proportional to the square of x, and y equals 40 when x equals 2. The formula is y equals kx squared. Substituting the values gives 40 equals k times 2 squared, so k equals 10. The formula is y equals 10x squared. Using the formula y equals 10x squared, let's calculate y when x equals 5. Substituting x equals 5, we get y equals 10 times 5 squared, which is 10 times 25, so y equals 250. Here's another harder direct variation example. The cost C of producing a football magazine varies as the square root of the number of pages P, given 36 pages cost 48 pence. Find a formula connecting C and P. Since C is proportional to the square root of P, C equals k times the square root of P. Substituting the values, 48 equals k times the square root of 36, which is 6. Therefore, k equals 8. The formula is C equals 8 times the square root of P. Using the formula C equals 8 times the square root of P, let's find how much 100 pages will cost. Substituting P equals 100, we get C equals 8 times the square root of 100, which is 8 times 10, so C equals 80 pence. Next, we'll focus on inverse variation. Our learning intention is to explain how to work out inverse variation formulae. Our success criteria are to understand the process and calculate the constant k to write the formula. Let's find the formula connecting y and x, given that y is inversely proportional to x, and y equals 40 when x equals 4. Since y is inversely proportional to x, the formula is y equals k over x. Substituting the values gives 40 equals k over 4, so k equals 160. The formula is y equals 160 over x. Speed s varies inversely as the time t. When speed is 6 km/h, time is 2 hours. Find a formula connecting s and t. Since s is inversely proportional to t, s equals k over t. Substituting the values gives 6 equals k over 2, so k equals 12. The formula is s equals 12 over t. Using the formula s equals 12 over t, let's find the time when the speed is 24 miles per hour. Substituting s equals 24, we get 24 equals 12 over t. Multiplying both sides by t and dividing by 24, we find that t equals 0.5 hours or 30 minutes. Now let's look at a harder inverse variation problem. Find a formula connecting y and x, given that y is inversely proportional to the square of x, and y equals 100 when x equals 2. The formula is y equals k over x squared. Substituting the values, 100 equals k over 2 squared, which is 4. Thus, k equals 400. The formula is y equals 400 over x squared. Using the formula y equals 400 over x squared, let's calculate y when x equals 5. Substituting x equals 5, we get y equals 400 over 5 squared, which is 400 over 25, so y equals 16. The number of ball bearings n varies inversely as the cube of the radius r. When r equals 2 millimeters, n equals 168. Find a formula connecting n and r. Since n is inversely proportional to r cubed, n equals k over r cubed. Substituting the values, 168 equals k over 2 cubed, which is 8. Thus, k equals 1344. The formula is n equals 1344 over r cubed,